Hi people, today we'll study about linear search and how to derive its time complexity in data structures. Okay, so first of all, here is the program. I'll explain you with the program itself so it will be easier for you to understand. You'll get a more clearer picture, right? So let's start from integer main because that's where we always start, right? It's the execution always in your mind when you are seeing this, you should always start from integer main as the execution begins from here as well. So whenever there is some function or something is called, at that time you jump to the function. Okay. So first in integer main, let us see what is here. This is an integer array and the values are given. You can use scanf to input the values also. I'm just doing this to make it a bit easier, right? So these are the elements. They don't have to be sorted for linear search. Okay. So what is the concept of linear searches? It first, see here we have integer x is equal to 32. Now what is x? X is the value which we want to search in the array ARR. Okay. So what will happen? In linear search, it will check whether 32 or x is present in the first location. Yes, no, it's not there. So it will move to the next location. 32 is present? Yes, it is present. Let me take a bigger, different number like 45 I'm taking. So what will happen? It will check x with 1, the first means ARR 0, the first element of the array. It's not matching. So then it will go to the next one. Then it will go to the next one and so on. Okay, so this will happen. And after that, if it is present, then fine, it will return the index. If it is not present, then it will display some kind of error message. So let us see what is happening. Okay, so here n they are taking a size of array. Now what is the size of array? This is integer array. So integer is 4 bytes, right? So 4 bytes into 1, 2, 3, 4, 5 elements. So 4 5s are 20. So 20 divided by x is what? 4 bytes. So 20 divided by 5 is 4, sorry, 20 divided by 4 is 5. So n is 5, means in this array 5 elements can be stored. Do you understand? Yeah, so size of is a function, an inbuilt function. It is already there in stdio.h. Okay, you know about inbuilt functions, right? Printf is an inbuilt function, scanf is also there. So these are already defined. The function's definition is written in stdio.h. So size of is also similar to that. So when you are writing size of and passing something in that, at that time what will happen? It will show you how much memory is occupied by that element. Now we know integer is 4 bytes, right? Means it depends on the compiler, but let us assume it is 4 bytes in this. Okay, so each element of the array will be of 4 byte. So this is 4 byte, this is 4 byte, this is 4 byte, this is and this is. So 4 into 5 is 20. So size of the ARR is 20. Now x is only one variable. ARR is collection of 5 variables, right? X is only one integer variable, so its size is 4 byte. So when we are dividing the total memory of the array by one of the element, means whatever this is, then what we are getting? 20 divided by 4 is 5. So number of elements is 5, right? So n is 5. So now we are passing this to the function search, and whatever it will return, that will be the result. We will see what we will do with the results later. Let us first call the function search. Now since we are writing it on the right side of equal to, so that means that search has a return type. Let us see whether it does or not. Yes, it does. It is having an integer return type. That's why we have a integer variable on the left side to just catch the value, to hold the value for a while, right? So let us pass the array, the n, and the value which we want to search, which is x. So you have already mentioned 45, so it is this. Let us go there. So what? Integer I. So I is equal to 0 and go till what? N. Now instead of doing this, what you can do? You can you can take scanf from the user and you can ask the user to input enter the number of elements in the array, then enter the array. So by doing this, what will happen? First of all, you will have to here allocate some value. So if you are allocating here 20 and the user wants to input only 5 values, so what are happening? The 15 other places are getting wasted. So this is a better way. So instead of this, you can do malloc also. Malloc will do what? Dynamically it will allocate the memory. Now if you want to like a malloc size of integer. Now if it is an integer value and it has 10 elements, so what you will do? 10 into size of integer, and here you will write malloc. Okay, so if you write it in this way, then also it will work when you are taking dynamically. Okay, let's not complicate this. Let us keep it like this only. Size of ARR and this. Okay, fine. Fine. So now let us go to the search function. Now when we are in search, what we are doing, we have we pass the parameters, the entire array is getting passed, then the size is getting passed and the variable. Okay, so we'll execute the loop from 0 to less than n, means till n minus 1. So if n is 5, so it will go from 0, 1, 2, 3, 4. So it is 5 elements, right? We are, if we go till 5, then what will happen? 0, 1, 2, 3, 4, 5 are 6 elements. So that will be array index out of bound, means array is not that long enough, right? So we will go to 4 only. So it is less than 5 and not less than equal to 5. Okay, now ARRI. What is the value of ARRI? It is ARR 0, means the 0th element. What is it? 1. So if 1 is equal to x, what is x? 45. Then return the index, means 0. 0 will get returned. This is the index. Then if it is not equal to, then the loop will continue. Okay, so I will be plus plus. So now I is equal to 1. So ARR 1 is 32. If 32 is equal to 45, then return 1, right? I value is 1 right now, so return that. Then I plus plus again, because this is not matching, that's why I will get continued. If we are returning back, then they will the loop will just break we will break out of the loop and come back to the void main. Wherever the function call happened, we'll come back here, right? And then the return whatever we are returning, the index will be stored in the value result. Okay, so this is what is happening. So it will loop till I equal to 3 and no match, so it will not enter the if statement. Now for I equal to 4, our value is ARR 4 is 45. Now 45 is equal to 45, yes, so return 4. Now we will return here, then 4 will be stored in results. Now if result is equal to minus 1, that means what? The element was not there. Let me write here 54. Element is not there. It is compared with 1, 32, 3, 98 and 45. It's not there. So what happened? It never entered if, right? If it never entered the if statement, then what happens? The loop will be over after 4, right? 0 to 4 only it is going. So we'll get out of the loop and we'll be here. So what we are returning? Returning minus 1. So now the value of result will be minus 1. Now if result is equal to minus 1, means it got no other value. From between 1 and 4 or 1 and any number, there will be no value as minus 1, right? I is iterating with plus plus, so 0, 1, 2, 3, so on. It can go up to whatever number it wants, but it will never be minus 1 in this case. So if we are taking minus 1, so that means element is not present in the array. And if it is some other value, then what will happen? If it will see this else condition, and element is present at index percentage %d. So whatever was the index, it will show percentage %d. Now let us compile this. Okay, so element is present at the index 4. Element is not present. Yeah, okay, not present because it is 54, right? Let me take 98. It is present. So let us see. Here it is present at the index 3. So 0, 1, 2, 3. If it is confusing for you that it is at the 4th place, but it is showing index as 3, I hope you understand what is indexing. It always starts from 0. So 0, 1, 2, 3, it is correct. So if you want to write like the location or place, so what we'll do, just add 1 to this result plus 1 and you will get the more user friendly answer, which is element is present at location 4. So 0, 1, 2, 3, no, start from 1, 1, 2, 3 and 4. Okay, so I hope you understand this. Now let us see how we will find out the complexity of this program. Now what is complexity? Complexity is how much time, we will look at the time complexity, because memory complexity will be fixed for this program. Why memory is fixed? Because array is taking a fixed amount of memory, this is taking a fixed amount of memory. So for number of elements, how much memory they are taking, that is the memory complexity. Now time complexity is how much time it is taking to execute this entire program. So this is constant, it will take a constant time. So let us assume that this is taking 1 unit. This thing is also constant, it is taking 1 unit. Everything other than loops are taking a constant amount of time. So we don't include constant amount of time in complexity, because we know that this much time will be taken, and it is very easy for a processor to do some task in a constant amount of time when we know it beforehandedly. But the problem comes when we have loops. Okay, so in this loop, what is happening? This if condition, see, to check this if condition, how much time will be taken? Just 1 unit. Why? Because you just have to compare, and that is all, right? But in this, you cannot do the next step unless the first step is over, right? You cannot execute this statement for I is equal to 1 unless I is equal to 0 is being over, right? So for I is equal to 0, it will take 1 unit. For I is equal to 1, it will take another unit. So in total 2 units. For I is equal to 2, it will take another unit, because you cannot do this parallelly, right? Unless one step is getting over, you cannot execute the next step, because it is dependent on the previous step, right? So for n is equal to 4, it will execute another time. So in total, how many times it will execute? For 0 one time, for 1 one time, for 2 one time, for 3 one time, and for 4 one time. So in total, it will execute 5 times. What is the value of n? It is 5. So how to write the time complexity? Let me make a comment here. It is written as big O, by the big O representation, and you write it here. So 5 is my time complexity in this case. So if we are taking a dynamic variable, let us take here n, because what we are doing, we are dynamically changing the value of n. If I change here, take n is equal to 1000, then what will happen? Our time complexity will be 1000 units, right? So if we have one for loop, then at that time complexity is big O of n. So now assume if we have here a nested for loop. If I have here a for j is equal to 0, j is less than m, assume that it is another variable, and j plus plus. And in this I am doing something, or whatever I am doing, like a printf I am doing. Printf high. Now to print something, how much time it will take? It will take only 1 unit, right? Because it is a constant thing, we have to just print the value. If we are doing addition, subtraction, then also it will take 1 unit. We'll just need the values and we'll have to add it, right? So this is for everything, these kind of things, time complexity is 1. But in loops it changes. Now what is happening here? Let me, so here the loop is starting, right? So in the outside loop, there is an inside loop. Now for I is equal to 0, the inside loop will work how many times? M times. Let us start from the inside. Okay, what is happening here? For j is equal to 0, it will take 1 unit. For j is equal to 1, it will take 2 units. For j is equal to 2, it will take 3 units. For j is equal to m, it will take m units. I hope you understand how it came. Right, let us assume m is equal to 3. So for j is equal to 1, the time taken is 1 unit. For j is equal to 2, time taken is 2 unit. For j, I mean 0, sorry. So for j is equal to 0, time taken is 1 unit. And for j is equal to 3, time taken is 1 unit another. So total for m is equal to 4, it will go from 0 to 4, means 0 to 3, 4 is excluded, and time taken will be 4 units, right? So every time this 4 units is happening, in the outer for loop, only 1 unit is happening. Do you understand? For I is equal to 0, this j loop will execute 4 times. For I is equal to 1, this j loop will execute 4 times again. For I is equal to 2, j loop will execute 2 times again. For I is 4 times again, sorry. So total j loop will execute m times, whatever the value of m is. And I loop will execute n times. So for one time, this will execute m times. For second execution, this will execute m into 2. For 3 execution, this will execute m into 3. For n execution, this will execute n into, let me remove this. So for this, now we have big O n into m. Okay, so this is my complexity. If I have a third for loop, which is going till O, then it will be big O n into m into O. Then another for loop nested inside. If it is when this for loop is over, after that if we have another for loop, then it's independent, because whether this for loop executed or not, or it got returned or whatever, the next for loop is not nested in this. So this will have n unit, this will have n unit. If you are adding n and n, then big O n plus n, then it will not be 2n. If it is 2n, okay, let us just take this 2n, but 2 is a very small number as compared to n. it is infinitesimally small as compared to n when you are talking about large scale systems. So like infinity times 2, if I'm doing it, is still infinity, right? So what we do, we just skip the this part, constant part, and it is again big O of n. So if two loops are there which are not less nested, then our complexity is still big O of n. But if they are nested, means this inside thing is dependent on this outside thing. The outside thing cannot increment its value unless this inside loop is over. So at that time it will be multiplication. So now if it is going till n only, so our this is n into n, which is n to the power 2, right? N square. Now if I have another loop inside, so it is n cube. So depending on the nested loop, this is valid for while loop also, do while loop also, it doesn't matter. All the loops which are going in a increment and decrement fashion. If it is going in some other fashion, then it will be a different concept that we'll discuss in future videos. If simple incrementation and decrementation is happening, then at that time what will happen? The number of loops which are getting nested, that will be in power. So if here we have two loops, so n square, provided that these two are same. Then if we have 10 loops inside each other, all are going from 0 to n, then it will be n to the power 10. So in linear search, we have only one for loop. So what is the complexity of linear search? It is big O of n. Okay, so I hope you understand. Thank you for watching.